Hi again. I'd like to talk a little bit about food source for land-based oyster farming. So, algae culture and aquaculture go closely together because algae is used to stimulate food sources. Algae is the start of the food chain, so a lot of your larval stages will simply eat larvae. Oysters in particular survive through their larval stages on feeding them algae. In a hatchery, a large proportion of your cost goes into production of algae. And they're plants, as opposed to zooplankton, these are phytoplankton. They range in size from around about 3 microns up to about 15 microns. And there are several main species, which we don't need to go into here. In a commercial application, algae are very important for hatchery work with any sort of bivalve mollusk, and the production of them is very, very well documented. But in a commercial sense, all these algae are naturally occurring. So if I've got a pond, any mill of water that I take from that pond is going to show me all sorts of life that occur in that environment. So to be a successful land-based oyster farmer, it's knowing the amount of fertiliser that you require. What you want to do is take, let's say the level's down here. So if I pumped water through there, that would be fairly stable population. So I've got the pond here, and there's a naturally occurring population here. Let's call it 2,000 cells per mil of water. If I'm pumping water through there and I'm not doing anything to this, then that's what I'll get to feed my oysters out of there. If I add fertiliser to it like any farmer does, I can cause this naturally occurring and stable population to increase. Let's call it 20,000. I've added urea, I've added a little bit of phosphate, a little bit of potassium. This urea is obviously nitrogen. And I've suspended it off the bottom. So if we looked at it side on, there's your water, there's a pond. I've got it floating on the surface. I've got a mix of fertilisers floating on the surface, because if they come in contact with the bottom, it's highly likely they'll just precipitate and won't be available for use for nutrition for the algae. So this concentration is known. I'm running tests here. I'm looking under the microscope. I know there's an increase in population. So I can control this by the types of fertiliser that I can add here. Most importantly, so that when I look under the microscope here, I can see that a large majority of the organisms are viable for oyster production. Now you have to know your science here. There's no two ways around it. You have to understand what these are, and you have to be able to recognise them under high magnification. So there is reasonable science involved. Okay, so I've got this population up, and I've manicured my fertiliser regime to suit the organisms, so that under a bell curve of naturally occurring organisms, I've tilted this in favour of the majority being the organisms that I need to grow my oysters. It's really not that difficult. You're just controlling this. Now, by maintaining your water flow, you're stopping this food chain from, well, we don't want it to end up being small fish. We don't want the food chain to develop beyond on what we want. We want this to be an algae production. We don't want it to be a zooplankton production. Now, how you control that is simple biological controls. I'm not going to go into that here. It's a little bit complex, but the idea of this was to give you a fundamental understanding of bell curve production in commercial farming of any description, but it's very important here for oyster farming. Standing crops here, by increasing the pond dynamics, can be around about 20 tonnes per hectare of biomass that you've added to the pond. So this is 1 hectare pond. I've got 20 tonnes of algae that have cost me electricity, pumping costs, and maybe half a tonne of fertiliser. That's aquaculture. That's farming for profitable aquaculture. I'm Kel Gordon, and thank you for listening.